All right, so for this example, solving rational inequalities, we're going to look at x plus 1 divided by x plus 3, which is greater than or equal to 0 or to 2. First step we want to do is make this equal to 0. So we want to move that negative 2 over. So I'm going to show you step by step how to do that. So here is the procedure and how to get it greater than or equal to 0. First, you subtract your 2. Second step, you find your LCD, your least common denominator, which in this case is x plus 3. Then you're going to combine the two fractions by subtracting them, simplifying the numerator until you get down to negative x minus 5 divided by x plus 3, which is greater than or equal to 0. So once we get that done, then what we can do is we can take the numerator and the denominator and set them equal to 0 and find our boundary points. So let's do that. We have negative x minus 5 equal to 0, which would give me negative 5. And we had x plus 3. We set that equal to 0. We get x is negative 3. So those are our two boundary points that we're going to use to define our intervals for this inequality. So I want to just use my number line here. Let's say that this is negative 5 and this is negative 3. So what it does is that creates three different intervals that I can look at and test to see if they are solutions to my inequality or not. So the first interval would be from negative infinity to negative 5. The second one would be negative 5 to negative 3. And then the third, negative 3 to positive infinity. So what we want to do is we want to test a value in each of those intervals to see whether or not those intervals are solutions to my inequality. So let's pick a number between negative infinity and negative 5. Let's use negative 6 for this problem. So what I'm going to do is I'm going to plug it in to the function when I set it equal to 0. And that function, remember, was negative x minus 5 divided by x plus 3. So I'm going to go ahead and show the substitution for this problem. And of course, it's the same for all three. So when I plug that negative 6 in, I get negative 1/3 as my answer. So what that tells me is that any number I plug in this interval from negative infinity to negative 5, the answer will always be negative. So I'm going to write negative up here in this interval. All right, so what you want to do is go ahead and test values in the other two intervals. I'll let you do this on your own. I'll get you started. Maybe you can test negative 4 for this interval and 0 for this one. So you can pause the video and try them yourself. Okay, so once you've tried them for the second interval, if you decided to use negative 4, you should have gotten an answer of positive 1. So that means that this would be positive. And then if you chose 0 for your third interval there, you would have got negative 5/3 as your answer, making this interval negative. So what that does is that tells me that the interval from negative 5 to negative 3 would be the one that I want to choose. Because, remember, and I'll go back here, the original was, the question was, find me all the x values that are greater than or equal to 0. So the reason I'm saying negative 5 to negative 3 is my answer is because it's a positive interval, meaning the answers that I get in there are always going to be greater than 0. So that's where I start. And I start by saying, okay, well, negative 5 to negative 3 is a possibility. But I want to test because remember it had that equal to part, and I want to make sure that negative 5 and negative 3 are not included, or if they are excluded. So that changes the sign of your your brackets, whether you use a square bracket or a round parenthesis, a round bracket. So if I take negative 5 and plug it into that original again, I end up with an answer of 0 over negative 2, which is 0. So actually, I want to change this, and let's go ahead and erase this and make it a square bracket. Okay, same thing with negative 3. I want to test it to make sure it's not equal to 0 there. And in this case, I get negative 2 divided by 0, which is undefined, which means it's not included. So I do want to keep that as rounded. So final answer, negative 5 to negative 3, where we include negative 5 but do not include negative 3.